In this session, we'll focus on reliability analysis, non-parametric tests like Spearman correlation, Mann-Whitney U-test, or Kruskal-Wallis H test to compare means. Now, starting with the reliability analysis. Now, if you are conducting a research, a primary research or survey-based research, you have to establish the reliability of your constructs. Now, construct reliability refers to consistency of results. For instance, if you've conducted a research, and if you use the similar instrument, similar measure on the same subjects and same condition, under same conditions, would you get similar results? If you get similar results, or if you fail to get similar results, so there are two conditions. So if you get similar results, this means that your instrument is consistent. And if you fail to get similar results, this means that there are problems of consistency with your instrument. So you can establish reliability in SPSS through Cronbach's alpha. Now, this alpha reliability, what it tells a reader or a scholar, is that your instrument that you have used for your research is consistent. So it will give you consistent results or similar results under same conditions and with the same subjects. Now, there are certain preconditions that one should know about reliability, or when they want to conduct a reliability analysis. If you've asked certain statements, or if you asked questions from your respondents, there should be more than one question asked in a survey instrument or in a measure. So you cannot establish reliability for a single item. So let's see how we can run a reliability analysis using Cronbach's alpha. For instance, let's say we've got these 4 questions. EI1, EI refers to entrepreneurial intentions. So EI1, EI2, EI3, EI4, EI5. These are 5 items. You can say 5 questions. You can say 5 observed variables or 5 indicators to measure reliability, to measure entrepreneurial intention. And now we want to report the reliability for this particular construct for entrepreneurial intentions. So in order to establish reliability, what you need to do is you go to Analyze, then you go to Scale, and then you select Reliability Analysis. So you press Reliability Analysis, and you are presented with a dialog box. Now, in this dialog box, on the left-hand side, you will see all these variables in your study. Let's say, and in this case, in this particular case, I'm interested in entrepreneurial intentions. So I will select only entrepreneurial intention. Now, here it is important to note that some of the scholars, some students, while early in their research phase, and obviously you will have more than one construct in your study. So what they do is they select all these items and put it in, and they try to establish the reliability of all the constructs together. That is wrong. In order to establish reliability, you have to check each and every construct separately. Now, if your construct has got sub-dimensions, you check the reliability of each dimension separately, and then you can check the overall reliability for that particular construct that has sub-dimensions. It is totally wrong to select all these items and put it in to check its reliability, because these are separate constructs. These are distinctive constructs. So you select one construct, you press this arrow button, and in the model, since we are, obviously there are different methods to select or to conduct reliability. There's alpha, there's split half, there's Gutman, parallel, strict parallel, but mostly alpha is used. So we'll focus in this video or in this session on alpha reliability, Cronbach's alpha. Now let's say if we go to statistics. So I want scale item if deleted, if item deleted, and I'll let you know what it means. And then just press continue and press OK. Now here we are with the results. Okay, now this is the case processing summary. Now we have 429 valid responses. That amounts to 99.3%. So there are 3 cases missing, which amounts to 0.7%, less than 1%. Now the alpha reliability in this case is 0.865, and this shows that our instrument is reliable. Now, how do you interpret this reliability? So there are 5 items. Now, first, let's interpret this reliability. So in order to do this, in order to interpret this reliability, let me open a Word document and let's put that in there. Okay, let's I'm opening a Word document so I can put in the results from alpha reliability in here and interpret them and discuss them in detail. Okay. Okay, here is a document. Let's first copy. Okay, I think the connection was lost. Okay. Okay. Now, so what we do is we select this reliability statistics table, press copy, and then we put it in here. Okay, so let's interpret this first, and then we'll format the results, and I'll guide you how to format the results. Now, Cronbach is alpha. So the value of Cronbach alpha would range from 0 to 1. So 0 means no reliability at all, and 1 would mean perfect reliability. But obviously, you won't get a perfect reliability. So how do you interpret this alpha values? So recommended value is greater than or equal to 0.70. But if it's greater than 0.6, you can say that it's good, or rather fair. If it's greater than 0.70, you can say good. If it's greater than 0.80, you can say very good. And if it's greater than 0.90, you can say excellent. So this is how you interpret your reliability statistics or Cronbach's alpha. But what if it's less than 0.60? This means that there are reliability issues to be solved. So there is very weak reliability. Now, having said that, in this case, we've got our reliability 0.65, which is greater than 0.80. So we can say that our reliability is very good. Now, what if you get a reliability that is less than 0.60? What if the reliability is poor? Now, how would you address that particular situation? If you go back to the results, there is a table, item total statistics. And this table has got 4 columns in it. Let me copy this in MS Word and put it in here. So if you see this table, so EI1, the mean of the scale would be 14.937 if this item is deleted. The variance would be this, corrected item total correlation would be this, and Cronbach's alpha, if item deleted, would be this. We are concerned with these two. The corrected item total correlation should be 0.30. It is the correlation of this particular item with the scale. So if there is lesser correlation than 0.30, this means that this particular item is failing to represent this particular construct. This particular item is not in consistency. It is not in good relationship with other items of the scale that are measuring the same construct. So you need a higher correlation. So your correct item total correlation should be greater than 0.30. In this case, all of them are greater than 0.30. So good enough. We do not need to actually maybe focus on any of the items. But what if there is less, our item to corrected item total correlation is less than 0.30? Now, in that particular case, you would need to delete that item. Let's say Cronbach is alpha if item deleted. So what does this mean? Let me read this statement. Cronbach alpha if item deleted. So what will happen to Cronbach alpha if this particular item is deleted? So if we delete EI1, the Cronbach alpha would be 0.835. So if we compare it to original alpha, that is 0.865, deleting EI1 would actually decrease your alpha value. Same is the case with the rest of the items. So if you delete any one of the items, your overall alpha would actually decrease. So you do not need to delete any of the items, right? So deleting any of the items would actually hamper or will actually reduce your reliability. So you do not need to delete any of the items. The scale is good as it is. Now, let's say, let's do some more and then we can interpret the results as well. So let's add a column. Insert columns to the left, and then let's say we write scale, and this scale was EI, entrepreneurial intentions. Let's do another one. Okay, if you are doing a thesis, you can report item total statistics. That's because you've got space, you've got time, you've got the word limit to obviously put in as much detail as you want. But if you're writing a research paper, it's recommended that you only mention the alpha and the number of items and do not mention this table. So let's say we remove this table and let's do another reliability for another scale. So again, scale, analyze, scale, reliability analysis. Okay, we have to remove this first. So we select them all, put it back, and let's say we do for ATE. Attitudes towards entrepreneurship, and we press OK. And if you see this now, here is a good case that we should discuss of what if the reliability is low. Now in this case, if we look at these two tables, let's copy these two tables and let's discuss how can we sort the problem of reliability in here. Now if we look at this table, the corrected item total correlation, it's particularly bad for 0.205. So ATE1 is not actually correlated with the rest of the items. So you can say that there is problem with this particular item. Maybe it's not representing this construct very well. And if you look at the next table, next column, the Cronbach alpha, if item deleted, is 0.584. So there is a jump in the Cronbach alpha. So if we delete ATE1, Cronbach's alpha actually improves. But does it improve good enough, or is there a good enough improvement in the alpha value? Well, in this case, it's getting closer, very closer, close to 0.60. So let's say let's delete this item from the reliability statistics. So your reliability would be now 0.584. So you can delete it, rerun the reliability, or just report it as is. So let's report it as is. So 0.584, and the scale is ATE. Let's go to the next one. Let's do another one. Scale, reliability analysis. We have to put this back. Let's do subjective norms. There are 4 items in norms. Just press this and okay. Okay, this is good enough, 0.767, and the reliability doesn't improve even if you delete any of the items. So let's put in subjective norms. So SN 0.730 and the items are 4. Let me see if I've added the value correctly. 767, sorry. So it is 0.767. Now that you have added all these, let's say we had these three constructs now, and we need to interpret it. So let's first design or set our table. You select the rest of the columns apart from the first one, centralize it. Then you select the whole table. You select no borders or bottom border, top border, and the bottom border. Now, it's always a good idea to write the whole name of the construct instead of the abbreviations, which you, so it's always a good idea to do that. Okay, but if you are using the interpretations again, when you are using the first time in a table, just add a note at the end, and you mention entrepreneur, it's entrepreneurial intentions. ATE is attitude towards entrepreneurship, and SN is subjective norms. Now you can obviously use these abbreviations in the rest of the table, so it's clear to the reader what these terminologies mean. Now, and this should be obviously in italics. Okay. Now let's interpret these results. Reliability analysis was established.
This is our one.
Very good. Greater than 0.70. Let's assume it's good, very good. Except for ATE was 0.5. However, since the reliability for ATE was close to 0.60, the construct with item was obtained. This in simple manners, you can interpret the reliability of your constructs. Since you deleted one item, you can also mention that one item was deleted to improve the reliability for ATE. So you can mention it like this: one item, which was ATE1, was removed to improve the reliability. Then please turn off your mics, please. Thank you. And make sure that you refer to the table in your text as well. Reliability statistics summarized one, let's say, and then you mention the table one here. So now this is how you can interpret your reliability statistics and report them. I hope this is clear, and I hope this helps in understanding how to conduct your reliability statistics. Now, what if you are conducting a research and your constructs fail to establish normality, the skewness and kurtosis that we discussed in our last session? What if the skewness and kurtosis is greater than the required range? And then you find out, okay, well, the skewness and kurtosis are greater than the required range, so I cannot conduct Pearson correlation analysis, so I have to go for Spearman correlation analysis. So Spearman correlation is actually a non-parametric alternative to Pearson correlation. And the results are the same, the interpretation is the same, it's just that this is what we use if we've got non-parametric or non-normal results. So in order to run Spearman correlation, what you do is you go to your let's go to our SPSS results. We go to analyze, uh, correlate, and bivariate. Now, why it's called bivariate? The reason it's called bivariate is that at one point in time, or at one in the results, you are at one time you are looking at the relationship between two variables. So the cross section of rows and columns only gives you the cross section of rows and columns will only give you the correlation between two variables. So analyze, correlate, bivariate. And let's say if I'm interested in conducting a correlation analysis between these two variables, let's say entrepreneurial intentions and self-efficacy. Spearman correlation. So we did discuss a two-tailed and one-tailed. Two-tailed when we do not know the direction of relationship, and one-tailed when we know the direction of relationship. In this case, I assume that the relationship would be positive. So if there are entrepreneurial orientation, that would obviously, or if there is self-efficacy, that would help increase the entrepreneurial intentions of the people. So let's say it's one-tailed, and what we do is we just flag significant correlation means that it will add an asterisk to all those correlations that are significant. Press OK. And if we see this table, it looks similar to what Pearson correlation results looked. Look at this one. So it's okay. We did uncheck the Pearson correlation. So both of these tables actually give us a similar sort of output. So if we can copy this into MS Word, just interpret it. Now, if we see the correlation coefficient is 0.252. So this is very weak. The relationship between self-efficacy and entrepreneurial intentions is very weak, but it is significant. It is worthwhile in your study to study this relationship, because the p-value or the significance value is less than 0.05. Even if it's less, it's less than 0.001. So your correlation is significant, even if we say that it's 1%, if the level of significance is 1%. So your relationship, although it's not strong enough, it is weak, but still it is significant. So in your organization or the type of organization in which this study was conducted, in those particular organization, the relationship might be weak, but it is still significant, and it can have an impact in the entrepreneurial intention of the people within the organizations. So this is how you use Spearman correlation. Once if you see that your results do not actually support normality, or your results have higher skewness and kurtosis, and there are distribution issues or data distribution issues in your data. So you should go for Spearman correlation. So interpretation is same as we did in our last session. So we can say it's a weak but significant correlation between self-efficacy and entrepreneurial entrepreneurial intention.